So let us represent the graphical motion here. So we have to study the variation of position with time and variation of let's study variation of position with time and variation of distance with time. Sorry, variation of velocity with time. So first we study here variation of position or displacement with time. Okay. Position or displacement with time. So how does position vary with time? Let us see.
Sir, will we study graphs today?
Yeah, today we are studying about the graph.
Okay, sir.
Let's draw the graph. You have here variation of position and or displacement with time. So let us see, we draw a graph of position with respect to time. So, so let's see. Let us plot our position on the y-axis and take time on the x-axis. So we have different graphs. We can have different graphs here. No. Yeah, I think this one is correct. So see, we have to see variation of position with time. So on the y-axis, here we have taken position, and on the x-axis, we have taken time. So what happens here? Let's mark the positions. We have here 0 and 0 of both time and position both. So let's say you have position here 5, 10, 15, 20, and 25. Let's have 30. So I will be drawing here few graphs and we will try to understand that what information is conveyed by them. So suppose I obtain a graph like this. Let this be graph A. So I have this graph A. Let us have another graph here. Let's say I have another graph like this. Okay, what information do we get from this first graph?
Sir, the object is at rest.
Yeah, so it says this graph points that the object is not changing its position with time. Every time we observe the position of the object is 25, 20. So this graph shows that the position of the object is not changing. So the graph A represents stationary position. Okay. So graph A shows that the object is at rest. So let's see A, it says the object is at rest. Then the second one, in the second one you have, let's draw another curve like this. So what information is conveyed by this graph?
Sir, can you give the time?
Yeah, you have, let's say you have time as
Sir,
1.
it is
Mhm.
at non-uniform
Sir, the object is moving at uniform motion.
motion.
In
Okay.
uniform motion.
Okay, we observe here that in every second, for example, in first second, there is a change of position by 5. In the next second, there is again a change of position by 5. In the next second, there is another change of position of 5. So in every second, the position changes by 5. So we observe here that their object covers equal displacements in equal intervals of time. Can I say here that the object travels equal displacements in equal
Yes,
intervals
sir.
of time? Yes. So for the graph B, I will say that the object has a uniform motion, or it's moving with uniform speed, right? It has uniform motion for the part B, right? Or it has a constant velocity. You can also say for the part B that it has constant velocity. Velocity is constant for the part B. Got it? Now let's try to draw another graph and see what information is conveyed by that. So what information does this graph convey?
So the object accelerates.
Yes,
Sir,
yes.
yes, sir. C is acceleration.
See, yeah, it is accelerating, or we can say it's a non-uniform motion. As
Yes,
the
sir.
graph is non-linear, so we'll say that it's a non-uniform motion. Okay, it's a non-uniform motion. So we have understood from the graph that what information is conveyed from the graph. Is there anyone who is okay? Anyone having any doubt in this?
No, sir.
No. Okay, so if anyone has doubts, so just clarify. Purujit, Yukta, Akshara, Navya, any doubts?
No, sir.
Okay.
No, sir.
Okay, so here we see another point to be studied in all of them. That is the gradient of the graph. So our next point here is gradient of graph. So we call it gradient, or we also call it as slope. So gradient or slope means the same. It's the one and the same thing. Gradient or slope of the graph, it represents. So the gradient or slope of the graph, it represents velocity.
Yes, sir.
Okay, so gradient or slope, it represents the velocity of the curve, right? Now, how do we find out the gradient or slope of the curve?
Sir,
At any, yes,
y2 minus y1 upon x2 minus x1.
okay. So to find out the gradient or velocity, you consider any 2 points on the curve. So for example, suppose I want to find the velocity for this graph P. So I consider any 2 points on this graph. Let's say I consider this point and this point B itself. Okay. So I complete a right angled triangle here to find out the gradient. I complete a right angled triangle here. So this is our right angled triangle. Now in this right angled triangle, we find out the opposite, that is the perpendicular divided by base that gives us the gradient. Okay. So the length of this perpendicular, if I make it some this, let this be point BD. So the length of the perpendicular would be BD, and this length would be equal to 15 minus 5. Everyone is getting the length of
Yes, sir.
BD. will be equal to 15 minus 5. Hence, we also call it as y2 minus y1, which will be 15 minus 5, and this must be equal to 10. Then divided by the time. So time here for this one is 1 and this is 3. So this portion is just equal to 2. So what would be the velocity represented by the graph OB?
So 5 meter per second.
5 meter per second. Okay. So for graph B, we can find out the velocity. We are finding velocity of B, which is 10 by 2, that is 5 meter per second. Anyone having any problem? Anyone who has not understood how we find out the velocity from position time graph?
Sir, once can you explain again?
Yes?
Sir, once can you explain again?
Once again. Okay. See, when you find out the gradient of the curve, to find the gradient of the curve, we take any 2 points on the graph. So it's not necessary I have chosen this point. You can also choose the initial point. Okay. You can also choose this point here. You can also choose origin. You can also choose this one. But I have chosen this point specifically. Okay. So now I complete a right angle triangle by dropping a perpendicular on y-axis and x-axis. So I get a right angle triangle. Now the slope or the gradient is equal to perpendicular divided by base. So perpendicular is our BD, which we obtain as y2 minus y1, and base is our bottom part, which is 2. So you get y2 minus y1, which is 15 minus 5 divided, that's 10 divided by 2, that you get answer. Or you can also obtain it by using the complete length of the graph. If you use the complete graph, so you have 15 will be the perpendicular and base will be 3. So if you divide 15 by 3, again you get 5 meter per second. Okay. So everyone has understood about all these three graphs of position time.
Yes, sir.
Yes, sir.
Okay. Now, what if I have a position time graph, something like this? Let's draw a position time graph like this. Suppose I have a position time graph like this, downward. So what does it show?
Sir, deceleration.
No,
Sir,
it's a straight
non-uniform
line.
motion.
Sir, I think
No,
it's not a position time graph. Time graph can't exist in that form.
yeah, a position time graph can exist in this form. Okay. The only thing is it shows us negative velocity. It shows our position is decreasing with time. Okay. So it is negative velocity. It's still the constant velocity, but negative.
Okay, sir.
Okay.
Yes,
So
sir.
shall we move on to the next graph? That is a velocity time graph.
Yes, sir.
Yes, sir.
So you have velocity time graph. The next is velocity time graph. So again, velocity time graph will represent the variation of velocity with time. How does velocity changes with time? So again, on y-axis, we will be plotting here velocity. So let's say here we take velocity, and on x-axis, we are plotting time. So you get here velocity, this one as time. So this is velocity in meter per second. and this is our time measured in second. Okay. So again, let's have velocity here 5 meter per second, 10 meter per second, 15 meter per second, 20 meter per second, 25 meter per second. Here you have 0. Same here you have 1, 2, 3, 4, 5, 6, 7. Now again, we can have three shapes of the graph. Let's say our first shape that we had taken. Let our first shape be the initial shape we took like this. Okay, let this be one of the shapes of the graph. Let us have this one, second one. Okay, so this is your graph A and this is your graph B. So what information is conveyed by A and B?
So A is at rest whereas B is in uniform motion.
No. Now here the information changes. Read the graph. Now the graph says that the object A is moving with the speed of 20 meter per second. On the y-axis, we have plotted velocity. Okay. So what does the graph A says? The graph A says that at time 0, the velocity was 20 meter per second. Right? At time 1 second, when the time was 1 second, the velocity was 20 meter per second. And when the time was 3 seconds, the velocity was 20 meter per second. So what do we get from this?
So it is at
Sir,
rest.
it's moving. Sir, it's moving with same constant velocity.
Yeah, it is moving with same or constant velocity. See, the graph is the same. The shape of graph is same in both of them, but they have their different meanings. If the same graph is in the position time, so it has a separate meaning. If the same graph is in the velocity time, so it has a separate meaning. Right? Since it is a velocity time graph, so here we observe that at every time it is having the same velocity 20 meter per second. So now the graph A shows it has uniform velocity or constant velocity. Uniform velocity or constant velocity. Then everyone has understood. Anyone has any doubt in graph A? Understanding graph A? So it's moving. It's not at rest. And all of you keep your camera on. Turn on your cameras. Yes, Navya, Akshara, are you there?
Sir, 1 second.
Yes, sir, I'm there. I'm opening it.
Yeah. So everyone has understood about the graph A.
Yes, sir.
So the same graph, you have a graph, a straight line parallel to the time axis. If it is present in the velocity time graph, it represents uniform motion. If the same graph is present in the position time graph, so it represents rest or zero velocity is represented by. Now, what does graph B represent?
Sir, the object
Sir,
is
uniform
uniformly
motion.
Yes?
Sir, it's uniformly increasing the velocity. It's uniformly
Okay, so
accelerating.
here velocity is increasing. In the beginning, the velocity was 0. Okay. Then slowly then after 1 second, the velocity was 5 meter per second. After another 1 second, the velocity was 10 meter per second. So here we observe the velocity to be increasing with time. Here we have increasing velocity with time. So this is your not uniform motion. This is not a uniform motion. Okay. The velocity is changing with time. Okay. So the graph B, it represents non-uniform motion, or we call it as uniformly accelerated motion. So we'll better call it as uniformly accelerated motion. Got it? Understood? Now, this graph is very important. In this graph, we have two important concepts. If you find out the slope or the gradient of the curve here. So how do we find out the slope? Perpendicular by perpendicular by base?
y1 minus
Yes,
y,
sir.
so y,
Yeah,
y2 minus y1.
yeah, y2 minus y1 divided by x2 minus x1. That is how we find out the slope of this curve. So here, if I find out y2 minus y1 divided by x2 minus x1, so see, I am actually finding out how the velocity is changing with time. So here, I actually find out how velocity changes with time. So you have this, the length is y2 minus y1, and here the bottom is x2 minus x1. Okay. So y2 minus y1, at this value our y2 is 15. Here y1 is 5. So you get 15 minus 5, that is 10. And x2 minus x1 is equal to 2. 3 minus 1 will be 2. So what value will this represent? Why, if I find out the gradient or the slope of this curve, so it will represent how the velocity changes with time. Okay, it will represent the variation of velocity with time. So which physical quantity is measured as variation of velocity with time?
Acceleration, sir.
Acceleration. So here the slope of the graph, will give you the acceleration. So here the slope represents acceleration. Got this? Anyone having doubt, right? Who cannot find out who cannot find out what the acceleration will be? Akshara, what will be the acceleration in this question? Yes, Akshara, can you tell what will be the acceleration? You are muted. Unmute yourself. Unmute first. You are muted. You are muted. You can't. Can you unmute yourself? Okay, just try now. You can. I think you can unmute. Do you see an option to unmute? Okay.
Sir, is the acceleration 5?
Yes, you have acceleration.
5
Yes.
meter per second square.
Yeah, you will have here acceleration as y2 minus y1 divided by x2 minus x1. So this should be equal to 10 by 2, that is 5 meter per second. So your acceleration is 5 meter per second square. Okay. So can you find out? Let me give you one more question and try. Yeah. Okay. So here I give you another question. Okay, here I have another graph C. Can you find out the acceleration for C also?
Yes, sir.
Okay, find out the acceleration for C, and those
So
who are unable to mute, message through the chat section. If you are unable to mute yourself, message through the chat section.
can you give the points?
Yeah, the points are there. Already you can see the graph and check the points. obtain the points from the graph only.
Okay.
So you can take either points, whatever you wish. Whatever points are available to you, you can take them. So which points are easily available?
So 5 to 15.
Yeah,
Or else you
5.
can take the whole also.
No, not from 5 to 15. For part C, you have the available points at 0 and 15. So that are the points you can easily read from the graph. Okay, anyone got the answer? I'm also expecting your answers through the chat section. If you're not able to speak up and you think that you might be incorrect and everyone will listen to you, no worries. You can message in the chat section, give a direct message to me. And if you do not know how to find out, inform right now.
So I'm not getting it.
Okay, who?
Sir Rohit.
Rohit. Okay, you are not getting how to find out?
Yes, sir, I'm not getting the C part.
Okay. See, in the C, identify the points which you can easily identify from the graph. So you have this point, you can easily read this point from the graph.
Yes, sir.
Okay. And you can also read the starting point of the graph. The starting point is 0, 0, and the last point is 15 and 4. Okay. So, can you get, okay, the coordinates of this point C would be 4, 15, and the coordinates of this point are 0, 0. So the value of y2 is 15 and y1 is 0. Can you find out now, Rohit?
Yes, sir.
Sir, I have sent the answer.
Okay.
Sir, even me.
So you find out here the velocity, the acceleration would be given as y2 minus y1 divided by x2 minus x1. So your y2 is 15 minus y1 is 0 divided by x2 is 4 and x1 is 0. So you have 15 by 4 and you get
3.75, sir.
yeah, you get 3.75 meter per second square. Let me check out. Okay. Harshit, Rohit, Sampath got correct answers. Okay. Thank you. All of you, you got your correct answers. So, so I'm giving you one more question in the similar way. Let us see who can try to find out. It's not calculation. You can easily tell from the graph. So you have displacement time, you have velocity time, and again you have displacement time. So you have a graph here, you have a graph here, you have a graph here, and let's say you just make it like this. So this is velocity time. This is your first point, second, and third. So out of the given graphs, which graph or graphs represent uniform motion?
So the
Second,
first
sir.
one,
So the third one.
The third one, which of the given
the
graph or
first one.
graphs?
So the third.
See, here you have both
second one.
graph 1 and 3. Both graph 1 and 3 represent uniform motion.
So you told that in the first figure it's uniform velocity.
Yeah, the first one is uniform velocity.
You were asking uniform motion, right?
Yeah, so uniform velocity, uniform motion. If it has a uniform velocity, so doesn't it have uniform motion?
Yes, sir.
Okay. So everyone got? Anyone having any doubt in these? Anyone finding any doubt? Okay, so let's see another question. Okay, thank you, Akshara, for informing. So you are given here two graphs. And this is your displacement time graph. So out of the graph A and B, the graph A and B represent the motion of two objects A and B. So which of the two objects is moving faster?
So should we send it in chat?
Yeah, you can send in the chat.
Sir, B.
B. Yes, B is moving faster and A is moving slower.
Yes, sir.
So, anyone finding any doubt? And just all cameras off again. Okay, some are on. Navya, any doubts?
No, sir.
Okay. So I'll be sending one assignment in the
Sir,
group. Yes.
what would be the explanation for B being the fastest?
Yeah. So the slope of B is greater.
Sir, because it's moving with acceleration.
Both are moving with acceleration. Okay. So a common logic you can use, the one which makes a greater angle will be the faster,
Okay, sir.
or will have the greater gradient. Okay. So B makes a greater angle, B has a
Yes,
greater
sir.
gradient, and hence B is faster. Okay. Okay, so bye all of you. See you again in the next
Thank you
class.
very much, sir.
Bye, sir. Thank you, sir.
Thank